So today in your warm-up, you explored some activities where you could look at what information would be enough to determine one specific triangle versus a variety of triangles. And in your list of things that should have determined one specific triangle, in addition to what you had learned before, that side, side, side was enough, and side, angle, side, we added at least two more. There was angle, side, angle, and angle, angle, side. Um, so we're going to explore those last two today, angle, angle, side, and angle, side, angle, and also one called hypotenuse, leg, which of course when we talk about hypotenuses, that means it's for a right triangle. So our objective today is to apply those three new postulates, angle, side, angle, 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 side, and hypotenuse, leg, to construct triangles and solve problems, and also to prove triangles are congruent by using those postulates. So you remember when we were talking about side, angle, side, that we talked about included angles. Well, today we have a new vocabulary word, and it is talking about included sides. So what is an included side? Well, it's the side that's between two consecutive angles in a polygon. Now this word consecutive just means in order. So if I'm looking at this triangle in this picture here, I can see P and Q. They're consecutive. First P, then Q. And so the side that's included between them would be this side PQ. So the first postulate we're going to talk about is angle, side, angle. And remember we learned side, angle, side was a thing, and now we're going to look at angle, side, angle. It's also a thing, and you can see the relationship there. This one had the side and the included angle. The new one has two angles and the included side, and we're going to accept this without proof. It's a postulate, and we're just going to tell you that if you have enough the information that you know that two triangles have two angles that are congruent, and the side between those two angles, the included side, is also congruent in both triangles, then we know that these two triangles are going to be congruent triangles. So if the two angles and the included side of one triangle are congruent to the two angles and the included side of another triangle, that's enough information to say that the entire triangle is exactly the same size as the other one. They are congruent. So how would we use this information to show that two triangles are congruent? So in this figure, you can see it's made up of two triangles. I'm going to color one triangle blue, just shade it in, the other one red. And we do have some information about these triangles as well. We know that the angle in this blue triangle has two tick marks. This one has two tick marks in the red one. So those are congruent angles. And these angles at the top also are congruent. The blue one has one tick mark. The red one has one tick mark. But what we don't know is we don't know anything about the sides. So angle, side, angle requires you to know that the length of that side that's included between those two angles. And since we don't know that, we cannot use this to tell the angles are congruent. So there is another relationship which also will prove that two triangles are congruent, and it is the relationship angle, angle, side. And this says that if I know two consecutive angles and then the next following side of a triangle are congruent in a pair of triangles, then I know that the triangles are congruent. So you can see in this picture, angle G has one tick mark, angle K has one tick mark, and then I can see that after angle G, I can go to angle J, and that has two tick marks. After angle K, I can go to angle M, that has two tick marks, and then the following side after M, so I went angle, angle, side, has one tick mark, and the same thing here, if I go G, J, angle, angle, and here's the side between H and J that has one tick mark. So that follows this angle, angle, side relationship, and that is enough to prove that those two triangles are congruent. This one is called a theorem, not a postulate. And the reason is because if we accept the previous postulate as true, this follows directly. And it follows directly because we have that third angle theorem that says if I have two angles in a triangle that are congruent to two other angles in the triangle, then that third angle is also congruent. So by the third angle theorem, I know from this picture that if I look at this, that this third angle, this angle H and this angle L, they are also congruent. So I'm going to put like 3 tick marks there. The third angle theorem says, all the angles of the triangle add up to 180. So if I have 2 in each triangle that are congruent to the 2 in the other triangle, then that third angle is also the same. And if I look at that, well, then we have the angle side angle relationship. So if angle side is true, then angle side angle is also true. And we know but angle side angle by that postulate means that the triangles are congruent. So let's try and actually do it with a few triangles here. So first, they're giving us some information, and a really good practice is when they give you some information, mark it on your picture. So on this picture that we have here, it tells us angle X is congruent to angle V. It should say I have a congruent sign here, so I'm just adding it in. I left off some important information here. All right, so angle X is congruent to angle V. So here's angle X is congruent to angle V. So I've got that marked on my diagram. And angle YZW, so let's see where YZW is. Here's YZW is going to be congruent to YWZ. So let's use blue for that one. So I'm going to put 2 tick marks here. Those are congruent angles. And then we have side XY is congruent to side VY. So XY is here and VY is here, and those are congruent. So I put a green tick mark on those. And I want to show that the triangle XYZ, so XYZ is congruent to VYW. And so why don't I shade those in? I'm gonna shade in XYZ. Oops. Let's see, I've got my eraser here. All right, let's see. There we go. So this is XYZ. I want to show that that is congruent to VW or VYW. All right, so what do I know about those triangles? Well, I know they have one, this side corresponds to this and is congruent. I know that this angle corresponds to this angle and is congruent. And they want us to use angle side. So if I'm using angle side, that means I need to know this angle right here, XZY and YWV. So how do I know that those two angles are congruent? Let me put a little mark down there so that we can, so I want to show that this angle is congruent to this angle. Well, what we do know is both of those angles are supplementary to congruent angles. And so if I look at this, this little blue angle here that I have marked is supplementary to this angle. And the same thing is true here. And we know that if two angles are supplementary to congruent angles, then they are congruent to each other. And so we're going to write this out. We're going to say, I'm going to save some time. I'm not going to rewrite all this. I'm going to say this is my given. Okay. Based on this, okay, what else can I say? Well, I can say that angle XZY is going to be congruent to angle YW, actually not YW, VWY. And what's my reason? Because angles angles that are supplementary to congruent angles are congruent to each other. And therefore, triangle XYZ is congruent to triangle VYW. So the last theorem we're going to talk about is called hypotenuse leg. And remember our vocabulary, a hypotenuse and a leg are sides of a triangle, but they're specific sides of a right triangle. And so they only, when you use those terms, you're talking about a right triangle. I think about this theorem as really a refinement of the side theorem. Because think about it, if I look at this first triangle here, I'm going to shade it in red. If I know the values for the hypotenuse and a leg, let's say that this was, I'm just going to call this H and this little a, then I know that I know the other side, because I can use the Pythagorean theorem to find it. So that would be h squared minus a squared, the square root of it. And if I know that those two sides, that a side and the h side, oops, I'm going to undo this. There we go. So if I know that a side and that h side are also the same lengths that are in this other triangle, so here I have a and h. Well, this third side in this triangle, this other leg, is also going to be that same length. So if the condition of hypotenuse leg, if I know the values for a hypotenuse and a leg in one triangle are congruent to a hypotenuse and a leg in the other triangle, well, then I know that third side is also congruent. And so we've already shown that side is a postulate that we use to show triangles are congruent. And so then this triangle would also be congruent. So in a right triangle, instead of having to know all three sides, it's okay if you just know one side, well, two sides. You know the hypotenuse and one of the legs. So here we have a diagram with, we can see has two right triangles in it. There's this one big triangle that's split into two smaller right triangles. And I can see that they are right triangles because I have this right angle here, and this, of course, is the supplementary angle, so it has to be 90 degrees as well. So can I use the hypotenuse leg? So what do I need to know? I need to know one pair of congruent legs and one pair of congruent hypotenuses. And I can see the hypotenuse is marked as congruent. So that's one check. So I'm halfway there. Hypotenuses are congruent. So that's done. Now I have to check out the legs. And if I start at the pair of legs at the bottom here, I don't have any information about their size. So that's not going to help me. However, this side right here is shared between the two triangles. And so I know that in this triangle, in the blue triangle, it has a length, and that same length is in the pink triangle. So that side is congruent to itself by the reflexive property of congruence. And so I have the requirements that I need. So we have a pair of legs that are congruent. And so that's the requirement for hypotenuse leg congruence. And so I could use hypotenuse leg to say that these two triangles are congruent. So what about this figure? Can we apply the hypotenuse leg congruence? Well, if we look carefully at the two triangles that are right triangles, which is what we need for hypotenuse leg. We can see that I can see the 90-degree angles, and I can see one leg that I know is congruent. I don't know anything about the other leg, and I don't know anything about the hypotenuse. So in this particular example, we cannot use hypotenuse leg. So we don't know if the triangles are congruent or not. They look congruent, but we don't know for sure. So pause your video and see if you can explain if angle side angle is enough to tell whether these two triangles are congruent. Okay, so let me see if I hope you've paused it and thought about it. I'm going to go through it and see if I can explain. And let's look at the shapes here. So what do we know? I can see that we have this side and this side are parallel. KL is parallel to NM because of that angle sign there. And then we have this dividing segment, which is a transversal for those parallel lines. So that's going to give me some more information. I'm going to know that this angle right here, this KLN, is going to be congruent to MNL because those are alternate interior angles. I also know by that same reasoning that this angle MLN is going to be congruent to angle KNL because that's also alternate interior. So remember, when we're talking about this being alternate interior, we're thinking about it in terms of having two parallel lines that are cut by a transversal. Let's see here if I can do the other one. There. And so these two parallel lines are cut by this transversal, which is the segment that's going this way. Let me pick a different color. How about like this line? I don't know if I can. Yeah, I guess I can move it. There we go. All right, and so those angles are congruent. And so what do we know? Well, I have an angle, and I have an angle, an angle, an angle, and the side that is in between these two angles is in both triangles. So it is the same length in both triangles, and so I do in fact have angle, the included side, and the angle. So that would explain that these are congruent triangles. Okay, so here is another figure. Pause your video and see if you can explain why you could, or how you could use angle side to prove that these are congruent triangles. Okay, so hopefully you paused the video and you're ready for somebody else's explanation, and let's see if it matches yours. So let's look at the two triangles first of all. We have this triangle on the top, and then below we have this other triangle. And are they congruent or not using angle side? So one thing I noticed right away is they share this side in the middle. So I can say for certain that this side is congruent in both triangles because it's the same line segment. I see that there is this angle that is marked congruent. Angle K is congruent to angle M. And the other piece of information we have is this word bisect. It says segment JL bisects KLM. So what does it mean to bisect? It means to cut into two congruent parts. So that will give me another angle that is congruent. So here we have angle KLM, and if it bisects it, that means that this angle right here, this KLJ, is going to be congruent to angle MLJ. And so let's mark that, and then we'll see if we have enough information. So this angle is going to be the same as that because segment JL bisected this bigger angle. And so now I can say I have angle, angle, side, angle, well actually, angle, angle, side, and I have to start with this angle, 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 side. And so therefore angle, angle, side does show that these are congruent triangles. Okay, so this last example asks us to determine if I can use hypotenuse leg congruence to show that ABC, triangle ABC, is congruent to triangle DCB. And if not, they want to know what's missing. So I want you to pause your video again and see if you can think about the relationships here and if you have an explanation. And then I'm going to explain it in a minute and see if it's the same as what you thought or not. All right, I'm back. Hopefully you thought about it a little bit and have an answer. And let's see what we can figure out here. So we have the two triangles. I like shading them in for some reason, but I know you can't really do that if you're working on a piece of paper, but I'm going to see. All right, so here we go. And it says, determine if you can use the hypotenuse leg congruence theorem. So I need to know my hypotenuse and leg. First I need to make sure I have a 90-degree triangle, and here I do. It's clearly these are 90-degree triangles. And because this side that's congruent is opposite. Excuse me for that. That was my alarm going off. All right, so if you look right here, the hypotenuses are congruent. So we do know it does that check mark. The hypotenuse is good. And then the other thing is we need to know one of the legs is also congruent. And that's what I like about these triangles that share a side, because that leg is going to be the same in both triangles. So we also have a shared leg that is congruent. So we got the hypotenuse congruent, the leg congruent. Yes, it meets all the criteria. So we can say by hypotenuse leg that those are congruent triangles.